Okay, in this video you should be taking some really good notes down in your Cornell notes that you got so that you can have this for future reference. Because some of this doesn't need to be memorized, but you do need to understand the process. So today we're going to focus on learning how to solve linear and quadratic equations. And in fact, they're not equations, they're inequalities. So even I'm going to slip up on occasion. So the first thing we have to think about is how are we going to solve this? And linear and quadratic are the two types of problems you need to know how to solve. And so the solutions look very different, as we saw starting in class the other day. So first of all, just defining an inequality. So an inequality is basically any symbol relating things. It's a mathematical, and let's finish this sentence first. Mathematical sentence describing two quantities that are not equal. So that word inequality means not equal. And that's what an inequality is. And so first thing we need to know when we say not equal, we're going to describe the relationship in a different way. And so these 5 symbols here, this first symbol and the second symbol, notice how they're similar. They both have this wide opening on the left-hand side. Both of these are describing things that are greater than. So greater than. That's how we'd read that from left to right. This next one is also greater than or equal to. So what we're saying is, it's something like, hey, I'd like to lend you, no greater than or equal to $50. So that means I'll lend you $50, but that's the most. And so I'm going to stop at 50, but I will do 50. So it's including that number. The next symbols, very similarly, they're both going the same direction. So they're opening to the right. They both mean less than. And the second one is going to be less than or equal to. So again, I'm less than or equal to. So we might say it'll take less than 5 hours to get to, the cabin. Less than or equal to 5 hours means it could take 5 hours exactly. So those are the inequality symbols that we're going to work with a lot. But there's one more that's interesting, and he is a inequality where literally it just means not equal. So that slash through the equal sign is what makes it not equal. Okay, now for some examples. So hopefully you got all those down. These examples, this is how we read them. So when I read this symbolic sentence here, 5 is greater than. So this is a greater than symbol. That's why we want to make sure we have our notes. So 5 is greater than x. And what's interesting is I could switch the statement around and say x is less than 5. And that means the same thing. Like those two both mean the same thing, just written backwards. So notice how I had to reorganize the symbol because obviously I'm writing it in a different direction. The next statement says x is less than or equal to b. So we're saying it's less than, and I have to just memorize the direction there. It's less than or equal to b. And again, I could reorganize that and rewrite this, and this would mean the same thing. If I wrote b is greater than or equal to x. It's just backwards, so of course I have to say it, do the letters backwards, as well as the sort of statement would say greater than or equal to x. So that's important. So what happens is, like, if we were asking you to write an answer, you could write it this way or you could write it this way, and you'd get both of them correct. They both would mean the same thing. So the second thing that you're going to start to have to be tested on is number lines. And so number lines are these lines that describe possible numbers. And they can also represent inequalities. And so number lines is what goes on this line. Number lines can also represent inequalities. And so what this looks like is I'm trying to represent where y is on the number line. And so they tell us that 3 is on the number line because that's what the relationship, that's what we call the boundary point. And so I find 3, and the thing is I can put any number I want wherever I want. So I'm going to put 0 over here. He's my friend. Remember, I love 0. And I'm going to put 3 right here because he's 3 away, because why not? 3 is there, 0 is there. Okay, so 3 is my boundary point. And so what I'm going to do is put a circle at 3. I'm not going to clean it up. I'm not going to color it in because circles, open circles, so add this to your notes, are for symbols like less than and greater than. We're saying don't include that number. But for closed circles, I use, that's when I'm saying it could be equal to. And so that's the key here, is that it can be equal. And so that's why we use the closed circle here. And so you'll just color it in. And so you'll get to, on the computer, pick the 2 circles. And so pick the proper circle and put it on the boundary point. Now we're going to describe where all the solutions are. And so the solutions for y are any numbers. I got to read this sentence. Y is greater than 3. And so I could at this point in the direction of numbers that are greater than 3. And those numbers are to the right. And so that's where I darken my line and I point my arrow. And so this is telling the world that, for instance, the number 5 is a solution to this y value, and in fact it is. 5 is greater than 3, right? And that was where my y went. You don't have to write all that down. I'm just kind of showing you some things that why these solutions are graphed this way. And so if you think of any number way over here in this direction, like the number 100, he is greater than 3, and so is 1,000,000, and so on. This next one is -2 is my boundary point. And so, of course, at -2, and really you can put -2 wherever you want. I like to put -2, and then I'll put 0 anywhere I want. It doesn't matter where you put the numbers. Usually the numbers will be graphed for you on the computer. But now we're ready to sketch our boundary point, and this time we close it in because it says equal to. And now we got to figure out which way to go. This statement is written differently than the previous, so I'm going to show you another way to decide. I like to test the point 0. And so if I put 0 in that inequality and I write the following, -2 is greater than or equal to 0. So if I put it in, I mean in for x. I ask myself if this is true. -2, is that greater than or equal to 0? Question mark? No, it is not. -2 is smaller than 0. So that tells me my solutions are not, they are not in the direction of 0. So I'm not going to go this way. I'm going to go this way. And so that's how I decide which way to go with my line, because I have to go in the direction of the solutions. I could have also looked at this and said a -2 is the biggest number because it has to be greater than or equal to x. And I'm trying to graph x with my blue line there. And so that means -3 would be a solution because he is smaller than -2. So you have a choice of testing a point, or, understanding what the sentence says. And I like testing a point. You'll see why when we solve equations. Okay, you've got those notes. Now let's take a look at how to solve linear inequalities. So solving linear inequalities, it's a lot like solving equations. So if you were good at that a while back, this will be a good unit for you to show some strength in. So what we're going to do is we're going to start with changing the inequality to an equal sign. So we're going to simply do that first step together and solve the equation to find the boundary point. So just like we were graphing the boundary point earlier, we're going to do that again here. So let's start with doing that. That first step is mostly review. You're going to solve the equation. So what that means is I'm going to change this to 2x minus 3 equals x plus 1. And I'm going to solve. 2x minus 3 equals x plus 1. I'm going to draw my line and solve. And so you can certainly try this on your own, or you can kind of watch me process through it. I like to get the x's together, so I'm going to start with minusing x because that will get my x's out of here, and it'll allow me to have x's that are positive. On the left, I'll have 1x minus 3 equals 1. And then the next step is I think I'm going to add 3 because I want to get the x's alone. And I get x equals 4. Well, that's nice. I get x equals 4 is my solution. So I finished step 1, just a review of step 1. The next step is to draw a number line and plot the boundary point. I'm abbreviating point there. So the number line is drawn for me. Let's take a quick moment and list the steps on the side here. So this is step 1. We go down here for step 2. We're going down to the number line. So I'm going down to the bottom number line here, and I'm going to plot the boundary point. Like I said on the computer, things will be labeled, but let's just put 0 here, and then we'll count to 4. 1, 2, 3, 4 is over here. And so I like 0. He's my favorite buddy, remember? So what we're going to do is plot the point. I'm not going to color it in until I know for sure. And so the way I know it's colored in is I want to go back up to my notes and remember that I shade it in if it's the equal to, but I don't if it's not. I'm basically telling the world don't include the number because it can't be equal. In this case, it says equal to right here. So when I look up at my notes here, I see this original problem had it equal to right there. So that means I'm going to shade it in fully. So color that circle in at 4. And now I have to test my next section, my next question that I have to ask myself is, where are the solutions? Where are the solutions? We're going to point in some direction. We only have one boundary point, so either we're going to point to the right or to the left. And we have to decide where they are. And so what we do is we test one number to determine where the solutions are. And my favorite friend is 0. So since 0 is over here to the left, so we see 0 on the left, this is where 0 is, he's my friend, I'm going to test him. And so that is what step 3 looks like. So here's step 3, let's write it out here. We're going to test it. What we mean by test it is we're going to go back to the original problem, so copy it down, 2x minus 3 greater than or equal to x plus 1. All we're going to do to test it is we're going to plug it in. So what we're going to do is we're going to put 0 where the x's are, and we're going to see if this is a solution. Minus 3, and then we have the 2. And so we're simply plugging it in to determine where the solutions are. And all we see when we do the left, it's really fast when you do 0. This left side gives me -3, and the right side gives me 1. And what I see here is a sentence that says, and you can write this down or you can just listen, -3 is greater than or equal to 1. Is that true? Is what you ask yourself. So what we see is that is not true, that is false. And so that tells me 0 is not a solution. So that tells me this is not a solution. So my line can't go to the left, it has to go to the right. And that's how you determine which way to go. So we have our line going to the right. We've finished plotting our point, okay? Because 0 is not a solution. And your last step will be to write the inequality. So you're going to write your final solution as an inequality. So we've made a beautiful sketch, but now we have to say, okay, what does that mean? What does it mean? X is what? And so just like on a test, you used to write things like x equals 5. You're going to do something very similar. You're going to write x, and you're going to tell me what the solutions are. So here's step 4. You're going to tell the world what the solutions are. And in this case, the solutions are starting at 4, and they go bigger. I see them going to the right, and so I say x is greater than or equal to 4. And I decided greater than because it's going to the numbers greater than. And I decided equal to because I colored it in, remember. So because I colored in the 4, I know it could be equal to, and because I went to the right, I know it's greater than, because those are numbers bigger than 4. And this is your final answer. It will be probably the graph plus the inequality statement. And so that's what we're communicating to the world. The possible solutions are any number bigger than 4. And that's how we test for solutions. So this next one, step 1, solve the equation. Step 2, test and draw your number line with your boundary points. So take a moment to solve the equation. So all I'm going to do is change this to equals to, and I'm going to solve. I kind of like to do steps as I go. So what I'm going to do is I'm going to distribute the -3, because that's what the parentheses do. -3x, and a -3 times -1 is +3. And now I'm ready to keep solving. Let's see, I'm going to simplify that. So -3x plus 5, x minus 7. I don't like negatives, so I'm going to add 3x, because I want to make the x's positive. I get 5 equals 3x minus 7. Adding 7, I get 12 equals 3x. Last but not least, divide both sides by 3. 4 is my boundary point. So this is now where I go down and I plot my point 4. So finding 0, finding 4 happens to also be 4, which is interesting. And now we're going to plot a circle, this time open. Okay, so an open circle because, going back to the problem, the solution cannot be equal to based on my original inequality. So I have an open circle, and now I'm ready for step number 3. Test one number, preferably 0, to determine where the solutions are. So maybe you add that little notes. Test 0. My best friend, 0. Okay, so we're testing 0. What that means is we go back to the original problem and we plug in 0. And we try to do it, efficiently. When I plug in 0 to this problem, I'm going to get 2 minus 3 times 0 minus 1. And I'm wondering if it's greater than 0 minus 7. And what I see on the right is -7. And what I see on the left is, let's see, 2 minus 3 times -1. 2 plus 3, is that greater than -7? Yes. 5 is greater than -7. So all I did there was simplify this to get a final number. This is also a calculator question. You could just punch this whole thing into your calculator to get 5. Try it right now if you didn't understand how to get 5. Take this left-hand side, plug it in. You're wondering if it's greater than the right-hand side. And in fact, it is true. And so that means 0 is a solution. So now, this time, I get to go in the direction of 0. So this time, I go to the left, and I get all the solutions to the left, and I have a new inequality to write. My final answer is an inequality statement describing x. I know 4 is the number, and the inequality symbol is less than, because these numbers are less than 4, right? And so less than 4. This is my answer. I'm describing all the possible numbers for x. So these are the 2 examples that should help you solve. You're mostly solving equations, just like you saw here. We're solving an equation, and then we got to learn these new steps here where we're drawing the boundary points. Try everything you can, and be ready to ask some questions tomorrow when I return if you have any questions on how to do these questions. Thanks for watching.